This looks mega complicated. Circle at one end, rectangle at the other end, and it's offset. But it's not on centre with each other. So it makes it a little bit more complicated to develop out. But if we can do this, we can do this. The same method, it's triangulation, a little bit more advanced, a little bit more thought goes into it. Now I'll break down how I would make this. Let's get going. Plan view and end elevation. We know what we've done here, we know what we've done here, and we know this. This is the important bit, obviously. Vertical height, which is a constant, plan length. So now we need to mark as points across where we're going to go, and this is a little tricky bit. This is the bit we need to think about. The trickiest bit is knowing where to put as lines and which points to line up to. The way I think about it when marking these lines up is into quarters. That's a quarter of a circle. That is 90 degrees, and that quarter ties up with this. So all these points across that quarter there will line up with C. All these points in this quarter here will line up with D. All these points up to 12 will line up with A, and 12 to 6 on this side, this quarter, will line up with B. All 90 degrees, all 90 degrees, all makes sense. All these points have now been transferred to the corners and the relevant places for fold lines. I'm going to transfer this information now to the top end elevation view. End elevation now, corners are indicated here, just to make sure we line up the correct points. So it's going to be number 6 to both corners. And then from there, just projecting these points back to those corners. That's almost everything I need to do to work out the development. The only thing I'm going to indicate now is my joint line. I'm going to have a joint down here. This is my joint line. Joint line indicator, we know the starting and the end points. When we bring it around, we know where it's going to end up being. Time to transfer this information now straight onto his development. I'll start from this line AB first when I draw the development, and this will be the starting point for his plan lengths and his vertical height. Here we are, AB drawn in, and this is my centre line, and this will keep everything nice, square and true, and we'll start plotting out his development. The golden rule is plan length against vertical height. This is our plan, so we take the plan length. The starting point was AB, so I'm going to start from the corners there. B to 12, which is A to 12 also. So I take my plan length, plot it on the plan length line, take up the vertical height, and this will give us our true length. So what is a true length? A true length, when we draw it on the drawing, it's in 2D. So we can't step across to find the actual dimension because the whole thing is going away from us. You can see it toes away from us. So we've got this dimension here, but that doesn't actually truly represent the actual length of what that is. So when we mark the plan length against the vertical height, that creates a true length. In essence, we're measuring the hypotenuse on each of these points as we go around. We'll take that dimension, we'll swing an arc across the centre line, and an arc across the centre line matches up beautifully. And from that point, this is our starting point of our development. And now for the next part of the development, we've got the first triangle in. Now let's get the next point in, and then that will be an indication of how we're going to develop it. So we're just repeating what we did on 12 now. So B to 11, which is the same as A to 11. Step the distance along as plan length line. And the golden rule is, as we all know, I'm going to say it again, plan length against vertical height. Vertical height is a constant. With number 11 in hand, A, strike an arc. On point B, strike an arc. The arcs are marked now, as we can see. That's simple enough. We need to get the spacings from here to here, and this works from our plan length. Using our plan length, we've already divided up into spacings. This is a true length in itself. What runs around here, we're actually looking at, we can actually measure it. So these spacings are true lengths, and these will give us an actual gap. If I said from 11 to 12, the same on both sides. The spacings on the dividers, mark that onto the arc, mark it onto that arc. That'll give us point 11. on both sides, and this is obviously 12. We're going to do the same, again, stepping these off all the way through to number 6 on each side. All marked out now through to 6. So that essentially this side here, all these marks around to this point here and this point here. And that is where we're at now. Now for the next stage. Now we need to mark these sides out. These are true lengths, so we can mark them straight off here and arc around. With that information in our hands, we can then do an arc from each point, indicating its true length. Now we need to find where it ends. We're going to use that again by using its true lengths. And this is telling it's from C to 6. Put it on its plan length and take that against its vertical height as usual. And simply put the point on 6. See where it intersects the arc for the other true length. And that'll be the next point of our development. Next points on the base. Let's line them up. This is now point D. And this is point C. For these points, it's just a simple case of going round from 6 to 0, 6 to 0, as we did round here. So it is just rinse and repeat again. So we've got most of it put in now. Just need to create the sides and where it's going to go around. However, you can utilise a joint line now to finish this development off. We'll take this true length from here, which is half from the joint to the corner. From the corner, strike an arc. Then for the opposite corner, this is the last point. This needs to be true length, so we need to put that onto a scale. So like as before, we're going to take its plan length, mark it onto its table. From there, we're going to get its true length. And as before, like that, like that. Mark J, mark that J. This will be the end of our development. Just line these points up now. We'll line these points up as well also. And that is simply, it's full development marked out. All marked out, all cut out, folds up beautifully. That's his joint line. As you can see, it looks really complicated, but when we've broken it down, it's really quite simple. It just boils down to one basic method, which is obviously triangulation, plan length against vertical height. Once we know where all points are going to go and where we're putting them all, the development is really quite simple. And this can be applied to any other problem that involves triangulation. When we understand what we're drawing, we can then understand the shape and how to recreate it. And that is real sheet metal work in action.